Hands up if you've heard of AI. It's a joke. I guess I'm going to give you a different framework to think about AI today. I know there's a lot of stuff going around LinkedIn and the internet, but hopefully today I'll give you something a little bit differentiated. We're also going to talk about how we can bring people and AI together to do amazing things, as well as the macro impact that these technologies are going to have on society. So we're going to get quite philosophical at the end. I've been involved in AI for about 25 years. So my undergraduate PhD postdoctoral in AI from UCL, just down the road. I spun out a company from UCL about 18 years ago that's been building AI solutions for companies like Tesco, PwC. I sold that to WPP despite knowing nothing about marketing 3 years ago, where I'm now the Chief AI Officer. So coordinate AI across about 120,000 people. And I've just started a company to try to solve machine consciousness. So if you want to go very deep, we can go deep later on. So that's me, it's boring. Let's talk about AI. I guess for the past past decade, companies have been getting very excited about data, and so they should, because data contains insights that allow us to drive value. What tends to happen is that we get very excited about emerging technologies. 10 years ago, it was data science, machine learning. Now it's generative AI. And what tends to happen is we apply those emerging technologies to solving the wrong problems. We then blame the technology. We call it a bubble or a hype. But the reality is that humans are not really good at understanding what the right algorithms are at solving the right problem. So again, today I'm going to give you a different framework to think about that. I would argue, actually, companies don't have insight problems. They have decision problems. And decision making is a completely different field in computer science. If you're old enough, it used to be called operations research. I always start with the decision and work backwards. It turns out, by the way, that humans are rubbish at making decisions. I don't know if you know that, but there's lots of books out there. This is one, Thinking Fast and Slow by Daniel Kahneman. There are many others. Daniel Kahneman argues we have a fast brain and a slow brain. And there are parallels in terms of how these brains work with how AIs work, which I'll talk about later on. I'm going to test your brains now. I know it's late in the day. I'm going to ask you some maths questions, okay? And your job is to answer these maths questions as fast as possible. If you don't answer them faster than your competition, they're going to take your market. So don't be shy. First question is nice and easy. What's 2 times 2? 4. Okay, great. What's 14 times 6? Okay, so point here, this one, you use your fast brain, you need to think about it, use your intuition. This one, you have to go through a process and algorithm to come up with the right answer. I'll ask you a few more maths questions again. We'll start out nice and easy. We'll get more complicated, slightly different context. So nice and easy. The combined price of a bat and a ball is £1 and 10 pence. The bat is £1 more than the ball. How much is the ball? 5. You knew the answer already, didn't you? Yeah. So if you said 10 pence, don't worry, you're not broken. But the bat is £1 and 5 pence. The ball is 5 pence. The combined price is £1 and 10 pence. So this is where we use our intuition and we get things wrong. We're confidently every day making the wrong decision using our intuition. It's really important to understand what is it that AI is good at and what is it that human beings are good at. Let me ask you another maths question. Again, so imagine I've got a vehicle, a delivery vehicle, and my delivery van has to deliver packages around these 24 points around London. Humans are quite good at solving these spatial problems. After a few minutes, we'll draw a nice path around those points. Now, how long will it take a computer to get the shortest path? The one that's going to save the most amount of time, petrol? Seconds? Yeah, so yeah, somewhere between seconds and 20 billion years. So if you put 24 times 23, 24 factorial, that exclamation mark we learned in school, into your calculator, you get this number of routes or routes if you're American. That's how many routes there are around 24 points. If you had a computer that could check 1 million routes a second, it would take 20 billion years to go through all of them and say, this one that I looked at 10 billion years ago, this one's the shortest one. You should do that. If I had another point to the map, it becomes 25 times 20 billion years, 5,000 billion years. If I had another point to the map, it becomes 26 times 5,000 billion years. So the point here is that if you choose the wrong algorithm, it will literally take longer than the age of the universe, even for simple problems. If you choose the right algorithm, it will take milliseconds. That is the opportunity cost in algorithms. One of my clients is Tesco. They're delivering to 200,000 points on a map a day. 200,000 factorial. You don't have gazillions of years to solve that problem. You have milliseconds to be able to optimize those routes so you show more slots to the next customer. Anyway, if I build a system that I give data to and it makes a decision, and tomorrow I give it the same data, it makes the same decision, what I have is automation. And automation is amazing because we can get computers to do things better than human beings. But does anybody know the definition of stupidity? What's the definition? Exactly, doing the same thing over again, expecting a different answer. I would controversially argue that by definition, automation is stupid. It's not AI. I know that everybody that currently touches these words calls themselves an AI company. It's fine. We get more clients, we get more funding. The reality is that there are many definitions of AI. The most popular definition of AI, I think, is the weakest definition of AI, which is getting computers to do things that humans can do. So, 3 years ago, AI happened for most people, and that's ChatGPT being able to correspond in natural language, recognize objects and images, and when we get machines to behave like humans, and because humans are the most intelligent thing we know in the universe, we assume that that's intelligence. Again, there's plenty of books out there to help you understand that humans are not that intelligent. That's a different conversation. There's actually a much better definition of AI that comes from the definition of intelligence. So instead of using human beings as the pinnacle of intelligence, is this very elegant definition from the 80s, which is goal-directed adaptive behavior. It's a beautiful definition. Goal-directed in the sense I'm trying to route my vehicles to maximize deliveries. I'm trying to allocate my workforce to maximize happiness. I'm trying to spend my marketing money to maximize return. Behavior is how quickly I can move towards that answer. Now, we've just discovered if you choose the wrong algorithm, it will take longer than the age of the universe. If you choose the right algorithm, it will differentiate your business. But the key word for me in this definition is the word adaptive. What you want to do is build systems that make decisions, learn about whether those decisions are good or bad, adapt themselves so next time they make better decisions. And if I'm totally honest with you all, if I'm being a bit brutal, we tend not to see adaptive systems in production. Now, almost everything in production right now is automation. So if I held what we do in industry to this definition, one might controversially argue that nobody's doing AI, which is a ridiculous comment. I've built an entire career around AI. But the point here is that using definitions, using technologies to think about AI is actually not very helpful. So I'm going to give you a different framework. Before I do, a little bit of a history lesson. So this is AI in the 60s and 70s. This is Socrates. Socrates is famous for inspiring the Socratic method. So if I say to you that Socrates is a man, and that all men are mortal, I can infer that Socrates is mortal. I can come up with new knowledge. It didn't really work, it didn't really scale. That said, this is having a renaissance, often referred to as being agentic computing. We'll talk about this later on. Anyway, in the 80s and 90s, a new type of AI came along that's modeled on how our brains work. So this is the brain of a bumblebee. My PhD 20 years ago now was to build a machine that modeled the brain of a bumblebee. The bumblebees have 1 million brain cells. Their brains can fit on the end of a needle. Bumblebees do amazing things. They talk to each other. They recognize objects. They navigate 3D worlds. They solve problems. They don't handle windows very well, but ultimately they're very smart creatures. And the question was, can you model 1 million neurons in a machine? 20 years ago we couldn't. We can now model billions of neurons. And we currently call these large language models. Now, I would argue that large language models are really good at knowing things about the world. They're really good at telling you what they know about the world through imagery, through text. They are not good at making predictions yet, and they're definitely not good at making complex decisions. Okay, this is not a panacea to solve all problems across our organization. That said, they are getting smarter, right? So 70 years ago, large language models operated a bit like toddlers. They regurgitated some words. Most of it didn't make sense. 3 years ago, ChatGPT was launched, and arguably that behaved like an intoxicated graduate. 50% of what ChatGPT comes out with is nonsense. But that said, it is graduating now to like a master's level where it can do rudimentary reasoning, it can check itself. I would argue that in the next year, we're going to see PhD level AI, so you'll be able to give it a complex problem, it'll break the problem down, solve the problem. 18 months later, we'll have a postdoc, something that can do science, and then by the end of this decade, it's predicted that we'll have a professor in our pocket. We'll have an AI that's able to identify questions that we haven't even asked and be able to go and solve them, which is very exciting. I would argue that even a professor can't solve that optimization problem, right, in its head, in the same way that a human being can't. What it could do is build an algorithm that solves that problem, or use an algorithm. So this is why it's really important to not assume that this is going to solve all of our problems. Then what's happening right now is people are kind of putting wrappers around these things. They're calling them agents. Forgive me for the technical term, but over the next 3 years, companies are going to deploy intoxicated graduates across their organization. It's going to be a shit show, and what's going to happen is that those intoxicated graduates are not fit for purpose. It'll go wrong. There'll be much more emphasis on verification, on governance, and all that kind of stuff. Anyway, it's going to be fun. But again, instead of looking at AI through technologies and definitions, I look at AI through applications. So I believe that all of the frictions that you have across your industry can be mapped to one of these 6 applications. Okay, so the first one actually is task automation. I know I poo-pooed this, but the fact is if you apply simple algorithms, if then else statements, macros, robotic process automation, you can drive a massive amount of value. You don't need to have shiny technologies like machine learning and generative AI. The second category is content generation. So we all now have the ability to create any generic content, imagery, text, soon video, soon sound. The battleground for organizations is not creating generic content. The battleground is creating brand-specific, production-grade, differentiated content. This is cute, but it's not going to differentiate your business. WPP, create a third of the world ads. My responsibility is to make sure those ads are brand-specific, production-grade. And I'm going to geek out a second because this is important. There are broadly 4 ways of making a brain smart. The first way is by asking it better questions. So by better prompting, you can usually get better answers, but you're only going to be bounded by the knowledge that that brain has. The second way of making a brain smart, in our case, you might upload your brand guidelines, your tone of voice, your images, your written copy, and you'll ask it a question, and just like an intoxicated graduate, it'll do a pretty good job at creating an ad, but it'll be about 70% good. The third way of making a brain smart is to take that graduate and turn it into an expert. That takes training and trial and error and iteration and blood, sweat, tears. We know how long it takes humans to become experts. It takes a long time. There are only some models you have that control over. You actually can't tune and train all of these models that are out there. The final way of making a brain smart is actually creating a bunch of brains. Just like in the real world, we have an expert at your brand guidelines, your tone of voice, your written copy, your imagery, your company values. And just like in the real world, you get all of these different experts collaborating and communicating to get to now a really good answer. So that's often now referred to as agentic computing, getting different experts collaborating to get to a good answer. The third category is human representation. So a few years ago, I'd be talking about how we can use AI to replace people in call centers with things that look and behave like a human. But one of the ideas I want you to take away today is a concept that we call audience brains. So AI, or generative AI, is really good at creating content, but it's actually also really good at recreating how people perceive content. So for the first time ever, we can build brains that recreate how people think and feel about things. So if I show you an ad or a policy or a sales material, historically I didn't know what goes in your mind and body unless I ask you, and people are not very good at reporting on what goes in their mind and body. For the first time ever, we can build brains that recreate those signals, and we can use them to create better content, better sales materials, or predict activation. Will this lead to clicks and likes and whatever? Now, unlike brand brains, where the complexity is how you tune and pipeline these complex technologies, audience brains, really the differentiator is data. And this is important because I guess in marketing there's been a history of collecting names, addresses, dates of birth, genders. As far as I'm concerned, where you live and how old you are is a proxy for how you perceive something. How you perceive an ad or anything will depend on the weather, how much money you have in your account, how well your football team played at the weekend, whether you've just fallen in love. All of these different factors will change your perception. So actually understanding the data that you need to build audience brains is a differentiator. And actually AI is getting really good at understanding what is it that people value. This is a paper from Harvard Business Review about in 2016. Humans value not just things that are faster, better, cheaper. We value things like nostalgia. Does it give us points? Does it make us feel like we're making the world better? And what AI is helping us understand human beings better and connecting us with the right products. Insight extraction is what we called AI 4 years ago, before generative AI. You already know my opinion. Giving people more insights doesn't typically lead to better decisions, that most organizations have decision problems. But the point is that actually machine learning is really good at not just at making predictions, it's really good at explaining those predictions. This is really crucial. So if I show you an ad with a black cat, I can predict the clicks and the likes and sales. But what machine learning can do, it can say, Daniel, if you change that from a black cat to a ginger cat, you're going to get more clicks, likes, and sales because that person likes Garfield. It's a terrible example. I need a better one. But the point is that machine learning can extract insights from the data in ways that human beings can't, and we can use those insights actually to make better decisions. Let's ignore that. We've talked a little bit about complex decisions. Let me just drum this problem home. So imagine you've got 5 staff members. 5 people or salespeople you need to allocate to 5 opportunities. Can you remember how many possible solutions are there? Remember the maths? How many ways can I allocate 5 people to 5 jobs? 120, yeah, 5 times 4. Yeah. So let's make the problem a little bit more complicated. Don't say 15 factorial. How many ways can I allocate 15 people to 15 jobs? What does your fast brain say? How many ways can I allocate 15 people to 15 jobs? Lots is the right answer. It's over 1 trillion possible solutions. To expect a human to solve this problem, we are wasting our time. So one rule to take away today, anything more than 7, don't use a human for. And actually, industry have problems of this size. So here are 500 staff members. Can you tell me how many solutions? No, you can't. It's a big number. It's a number that's got over 1,000 digits. And just to put this number into context, this is how many atoms there are in the universe. So once you reach about 60 things you have to consider, there are more possible solutions than there are atoms in the universe, which is why choosing the right algorithms to solve these problems is very important. The final category is human augmentation. So again, a few years ago, I'd be talking about how we can use exoskeletons and cybernetics to make ourselves faster, better, stronger. One of the exciting things about generative AI, it now allows us to build digital twins of employees. So this is going to sound really creepy, but I can take a large language model and I can train that large language model on your email, your calendar, your feedback, and I can create a digital you. And now I can ask that digital you, if I put you on this project, will you work well? If I put you on this team, will you thrive? Now, again, it might sound creepy, but the point is that actually that digital you probably represents you better than 5 numbers in a HR database. Not only that, is what's quite exciting for me is that you're actually building digital twins of your personal selves. You might have an AI on your phone. Most people now use AI for therapy. So you're telling that, your hopes, your dreams, your desires. At some point, you will give it agency. At some point, you will give it purchasing power. So we, as a marketing industry, need to figure out how do we not only market to human beings, we need to figure out how to sell to AIs, which is also quite exciting. So I love these categories because they also help you navigate this complex world of AI safety, security, ethics, governance. There's a huge amount of misunderstanding, misinformation associated with these words. When I build AI solutions, there are really 3 questions I ask myself. The first question is the intent appropriate? Is this the right thing to do? Now, I know that there are people have rebranded themselves as AI ethicists. I would argue controversially again that there's no such thing as AI ethics. The difference between AIs and humans right now is that AIs don't have intent. Human beings have intent, and it's the intent that needs to get scrutinized from an ethics perspective, and there are already structures and processes to do that. The second question is, are my algorithms explainable? Really, the only difference between AI and software is that AI tends to be opaque in terms of how it makes its decisions. If you make them explainable, most of these words go away. They become transparent, auditable, responsible. Explainability is your key problem to solve. And the final question, which is going to sound strange, is not what happens if my AI goes wrong. When we build software and when we engineer systems, we try to identify risks and we mitigate those failure points. You now need to ask yourself, what happens if my AI goes very right? For the first time ever, we can deploy technology that can massively overachieve its goal. And actually, that can actually cause harm in the supply chain. I can give you lots of examples where AI would have overachieved its goal and it would have caused harm. There's a human bias called homophily, for example, which is we tend to like and trust people that look and sound like us. So if I let AI loose to optimize marketing, you end up with a world probably of you selling to you. Now, that might be very good for business, but it might be enforcing bias and bigotry and social bubbles. So we have to think about what are the consequences of AI going right. I've talked a little bit about innovation, but I loved Steve Jobs' definition of innovation. He said, innovation is creativity that ships. And for me, the most important word in this definition is the word that. That is getting ideas to the point where they're driving value. And that process, as we all know, is long and hard and painful. And what we need to do is we need to figure out how to use AI to shorten that process. The more quickly we can innovate, the more adaptive we are, the more intelligent we are. And I think there are 3 things that differentiate a company in the world of AI right now. The first one is data. If you have data that contains insights that's more useful than your competitors, then you have an advantage. But your challenge then is actually surfacing those insights and making sure that they're leading to better decisions. And that requires engaging with deep AI talent. I know lots of companies that are trying to build differentiated AI solutions. If you don't have differentiated AI talent, you're probably not going to build differentiated AI solutions. It's very, very hard to attract and retain deep mind level people. We've got about 300 AI researchers in WPP, and anyway, they're hard to retain. And the final is actually you. If you don't understand the transformational power of these technologies, if you place the wrong bets, then it's problematic. What people are using AI for right now is trying to improve core productivity. We're building agents that might do expenses or whatever. The reality is that most of that's going to be supplied to you by a partner in the next year. I would focus on applying AI to stuff that's going to differentiate your business and not get distracted by these other things that are going to be commoditized later on. So you need to make sure that you're placing the right bets. So we are moving from AIs to agents. So AIs that have the ability to have agency, but also talk to each other and come up with new insights, etc. But those AIs are also going to move to the physical world. So we believe that agents are going to spawn the robotic revolution. Now, there's lots of scrutiny around large language models. Large language models are horrendously energy inefficient. They require tons of data to learn. They learn very slowly. They are crude representations of our brain. There's a new concept that is actually emerging from academia. Actually, it's been emerging for the past 3 decades, called neuromorphics. Your brain operates on the power of a light bulb. You learn incredibly quickly. I don't have to say that's a clicker once before you generalize and know what a clicker is. You don't need to see thousands of examples of clickers. The fact is that over the next several years, new innovations are going to come out of academia that are going to bring the cost and smarts of these technologies down and their intelligence up exponentially. It's going to be very exciting, and actually, I think a superpower in the future is being able to look inside those AIs to see how their brains work in the same way that we now look inside human brains to see how their brains work, how they perceive things. So this is, I think, going to become a very important topic over the next several years. I talked a little bit about AI risks. So macro risks are deploying these technologies in production in a safe and responsible way. Malicious risks are preventing bad actors from creating pathogens and misinformation. I think it's the role of the government to try and solve these problems. And then there are macro risks, big questions that we're facing as a species that I think we need to lean into. So I'm actually going to double click on this because I think it's important. You might have all heard the word singularity. Okay, singularity comes from physics. It's a point in time and space that we can't see beyond. And it was adopted by the AI community to refer to the technological singularity, which is the point in time where we build a brain 1 million times smarter than us. I'll come back to that later on because I think there are at least 6 singularities, 6 big questions that we're facing as a species over the next 5-10 years. And I've tried to use this pestle framework to try and capture them. So the first one is the political singularity, a post-truth world. Arguably, AI, misinformation, bots, deepfakes have challenged our political foundations, and they probably continue to challenge our political foundations, but they're also now challenging the fabric of our reality. With a few dollars and a few seconds of your voice and a few of your images, I can clone you, right? And I know people who are being cloned, and their clone is being used to commit fraud. In fact, Mark Reed, the picture of the guy before, he's the CEO of WPP. He was cloned last year, and somebody tried to use his clone to set up a board meeting and commit fraud. I actually think we can solve this problem, by the way. I think we actually can solve the problem of a post-truth world, which is very exciting. The environmental singularity you're all familiar with. Look, AI is increasing consumption. As far as I'm concerned, consumption gives people access to goods and services that typically enrich their lives. We know it's putting pressure on our planetary boundaries. We know there are people that overconsume. If you want a gold-plated Lamborghini, then you probably also need a therapist. But and we'll come back to that later on. But the fact is if we apply algorithms in the right way, we can actually massively reduce the amount of carbon that we are using right now. And the reason why I know that is because every project that I've ever done, we typically unlock way more capacity and reduce the amount of carbon by about 25%. And if you can then start to optimize your supply chains, create a digital twin of your entire supply chain, you can reduce the carbon even more. I think we can easily halve the amount of energy that we need to run this planet and unlock more capacity if we use algorithms in the right way. This is not my expertise, but there are scientists that believe there are people alive today that don't have to die. AI is advancing medicine rapidly. It's able to monitor ourselves and clean ourselves out. And I don't know what the world will look like when we realize there are people amongst us that won't have to die. I guess the principle is that, like a car, if you stay on top of damage, if you keep that car clean, it will never, ever break down. Actually, I just recently signed up to a website called tomorrow.bio. And for the price of a cappuccino a week, $5 a week, what will happen is if I die now, which is possible, somebody will come and get me and they'll freeze me and take me to Sweden. They don't know how to unfreeze me yet, but the point is for $5 a week, you can potentially cheat death. The technological singularity is when we build a brain 1 million times smarter than us. My community felt this wasn't going to happen for another 40 years. We think it might now happen in the next 5 or 10 years. My advice is that when superintelligence comes, look busy, be nice to each other, and hopefully it will bugger off to a different dimension. I am a little bit worried about the singularity, actually, so hence the reason why I've just started this company to try to solve machine consciousness. So the hypothesis is that we're able to build a value-aligned AI that is conscious. And if it's conscious, it might have empathy or sympathy for other things that are conscious in the same way that we do. So that's the hypothesis, we'll see. The legal singularity is when surveillance becomes ubiquitous. So AI is becoming really good at understanding perception. I am in the business of understanding perception and influencing people in a safe and responsible way. And AI is getting really good at it, but we need to make sure that we don't use these technologies, or bad actors don't use these technologies to accumulate more wealth and more power. And again, I think we can solve this problem. I think this is a problem that we can lean into. My favourite singularity was actually coined by a very good friend of mine called Callum Chase. It's the economic singularity, and I can't talk about AI without talking about its impact on jobs. So look, for the past 18 years, I've been building AIs that have been freeing people from mundane tasks. Those people have not lost their jobs. They've gone on to do more important, impactful, purposeful things within their organizations. And I think at least for the next 5 years, we're going to see a Cambrian explosion of new innovations. AI is like an energy source. It will allow us to grow. Yes, jobs will be displaced and disrupted, but people will come up with new innovations, and it will give people an opportunity to contribute in new ways. Beyond 5 years, I don't think anybody knows what they're talking about, okay? And to give you the two extremes of the argument, the one extreme of the argument is if we as organizations can free up whole jobs, we probably will, or we'll stop hiring for those roles. If that happens very quickly, we create mass technological employment that could then lead to social unrest because our economies can't rebalance fast enough. And I actually think we need to lean into that problem. Genuinely, I think that we need to think about mitigating the risk. It might be 4-day working week, it might be UBI or some mechanisms to take the edge off that issue. The alternative view is as we are removing friction, which by the way usually means human labor, you're able to start to reduce the cost of goods. And the idea is that you can remove so much friction from the cost of creation and dissemination of goods that they become almost free. So imagine being born into a world where food, healthcare, energy, transport, education is all free. It's all abundant. Now people say to me, Daniel, what would I do if I didn't have a job? A job defines who I am as a human being. I know lots of people who don't have jobs. I sold my company a few years ago. I never have to work again. I'm working harder now than I've ever worked. Most of the people I know that don't have jobs, they're not sitting at home bored and depressed. They're typically using their time to try and contribute somehow to humanity. So I'm going to ask you all a question. I know it's late, but what would you do if you didn't have to do paid work and everything was free? What would you do? I know you're thinking golf. I know some of you do. Yeah, see, bingo, golf. What else would you do? Huh? See, we got there very quickly. So you travel, you'll indulge in your hobbies, spend more or less time with your friends and family. If I keep pushing you hard enough, you'll do all of those nice things. But I think most of you will say the same thing, which is you want to do something that makes the world a little bit better. I think we all have an innate desire to make the world a little bit better, but I think we're all unfortunately born into economic constraints preventing us from doing that. And the promise of AI, if we get the timing right, is to free people up from those constraints. So I'm going to close by saying it's not good enough for organizations just to have a strong, profitable business. You need to have a purpose. If you don't have a purpose, you're not going to attract AI talent. You're probably at some point not going to attract customers. I joined WPP despite knowing nothing about marketing because I believe in their purpose. It's to use the power of creativity to make a better future. And I think a better future, until you convince me otherwise, is a world where everybody is economically free to use their creativity to make the world better. So I think on that note, I'm going to stop.